keynote speaker, Neil Chue, who is the director of the Software Sustainability Institute. And it is my pleasure to introduce him for the second time in recent months to set the scene and to sort of lay out all the issues for us and to really get us kick-started on discussing software preservation today.
About shoeboxes. So how many people have heard of Andy Warhol? Probably quite a few of you, yeah. That's good. So Andy Warhol, artist, maverick, a number of different things. The world was this collection, shoeboxes. He called them time capsules. So there are 612 of these boxes in the Andy Warhol Museum and Archive, and the instructions that were given were that they should be treated as a piece of artwork, and that's it. So here you have a whole set of seemingly identical boxes, with the only thing that's indicated on them is a date, and then sometimes a label. So you can see there, one of them says gems and junk, another one says like October 1979. Most of them have no labels whatsoever. And over the last 7 or 8 years, there's been a movement that's going, led by a number of different curators, to open these boxes and try and understand how to preserve the contents that's inside. And the challenge here is that they really are a random set of stuff. So in many cases, they are simply items that Andy Warhol seems to have picked up from the street as he was walking along between his home and his studio. Sometimes they are things that have perished. There's no ordering to them. There's no sense of why they're important to be collected in one different way or another. Basically, they're an archivist's nightmare. These are boxes where seemingly there is no reason for why they exist apart from the fact that the author has said they're important. Please preserve them. And you can kind of see there's all sorts of random stuff. The hope is that one of these boxes will come out and it will be the kind of like the sketches for some famous piece. But generally they're just they're like ephemera. They have importance because of the way that they have been used, not because of any other thing that's been attached to them. And so what do you do as good archivists? You try and ensure that you have done your best in recording what's in it. You do your best to try and create standards and use existing standards to ensure that everything is recorded so that it can be indexed, so it can be searched, and so on. And so all of these things can be done because the ultimate goal of this project is to be able to make the contents of these boxes available to the public and to researchers through different means. The first one that they've done is through this app that you can get so that you can digitally see what's inside these boxes. You can go back, you can kind of understand a little bit about what other people have thought these things meant. So why am I kind of talking about shoeboxes in a talk about software preservation, you might ask? And it's a very good question. I think mostly it's because software is actually a really difficult thing to display on screen, where shoeboxes are visually very easy. But the main reason is that these kinds of things, these Andy Warhol's time capsules, present an analog version of what we're having to deal with when it comes to software preservation. So in software preservation, what we have is not just a single item, a shoebox with a label on it, but what we have is a really complex set of different things, all interlinking with some kind of meaning associated between the different things that are in that box. But it isn't always clear what that meaning is, because we can no longer talk to its creator. So if you think of software, the challenge we often have is that by the time we realize we need to preserve it, we can no longer talk to the authors, or the authors have forgotten the intent of why they connected A to B or included library C in the piece of software. So actually we have a very similar problem to the archive, the Andy Warhol archive, in that it's only by bringing in experts from outside and applying best practice that we can make any headway with software preservation. And so one of the challenges is that when we talk about software preservation, we're often talking about some of the big things that have gone in the past. So for me, I grew up in the UK. I grew up in the time in the 80s, where the big thing that they were doing was something called the Digital Doomsday Project. Digital Doomsday was an attempt to recreate the exercise that was done in the Doomsday Book, which you can see a little excerpt from on the left here, to create basically a census, a study of one day across an entire country. It's an amazing project. There was loads and loads of schools involved, bringing together lots and lots of information, making use of the latest and greatest technology here. These BBC Acorn microcomputers, laser discs. And so when we often think about things like software preservation and digital preservation, these kinds of things get brought up because they are the things that are remembered by people. They're the things that stay in the public memory. And the challenge here is that actually a lot of the problems here tend to be around hardware. They tend to be around the fact that only 10 years later, it was almost impossible to read the discs. In 10 years, the hardware that was used to implement the Digital Doomsday Initiative has completely moved on. And even when you try and kind of recreate it in different ways, so the BBC had a project to basically kind of get all of the information off of these now obsolete laser discs and make them available through a different method, in this case a website. As you can see from the top of the bar there, even that kind of fails in the end. So we're always talking about the data and we're talking about the hardware. We're really talking about the software itself. So we don't talk about all of the things that were required to load and display the different information that was collected in the Digital Doomsday Book. We don't really talk about the different technologies that were used to create this port. What we tend to care about is the actual digital objects themselves, the pictures, the text, the sound, and so on. So who are the people who are starting to care about the software, and why are they doing it? So one example is the kinds of industries where you really do need to have a long-term view of the things that you are producing. And this actually comes from a Digital Preservation Coalition briefing day from quite some time back now, where Sean Barker from BAE Systems was talking about what they do in terms of the engineering industry for models which have to be understood for a long time because of some sort of regulatory or legal compliance requirement. So in this case here, we have a computer-assisted design model of a component where the lifetime of the product might be in the order of decades, so here 70 plus years, but the lifetime of any particular piece of software that's been used to read in that file is probably 6 months. So here you get one aspect of why software preservation is so difficult. Software changes very rapidly, and it's not just the software itself. It's also all of the dependencies that your particular piece of software that you're trying to preserve might rely on. In any case, even if the individual versions offer the functionality of being able to load up the particular model, the lifetime of a particular piece of software is probably in the order of a small number of decades. Eventually, companies basically go out of existence. Particular types of ways of doing things, processes change. In some cases, what happens is that we realize that there are new techniques which make software obsolete. And yet, you may still need to get back to the software that was originally used because you want to read these models. So in some industries, the way they do that is by abstracting away the digital object, in this case the CAD model, away from the software that was used to produce it. And so for this initiative, LOTAR, that's what they do. They work out a way of separating the software and the data, which is great. But quite often that's really difficult to do. And this often comes up when you talk about pieces of software which are not discrete individual things that you're running on a computer that's sitting in front of you, but are instead services that rely on other services. And a really good example of things like this are anything that you interact with on the web. All of these internet services typically are not just a single thing, but a set of pieces of software all interacting, all communicating, and thus making it very hard to identify what is the thing that you are trying to preserve. So one example I can give you here, if you've never tried it and you're on Twitter, is a wonderful service called Poetweet, which basically creates poems out of your tweets. It's amazing. As someone who is a poet and a writer, this is amazing because I can just get it to do all of my writing for me. And it's actually amazingly good. Well, I don't know. You can see an example on the right there. The challenge when you look at this in terms of software preservation is, what is it that you're preserving? So I could preserve just the software that runs behind the Poetweet website. So that is simply a piece of code which does a number of things, connects to a number of different services, and is relatively standalone. It has nice, clean APIs, so it has standard interfaces that are used to connect to other services it calls. But the challenge here is, even with standard APIs, these change. Twitter is notorious for doing this. Twitter changed the terms and conditions, meaning that software can break very quickly, and you need to keep on updating it to make sure it keeps on working. If you're preserving this, another question is, what are you trying to preserve? Are you trying to preserve the software itself so people can understand how to reuse it? Or are you really trying to preserve the intent of the software, which is to generate poetry? So why are you trying to preserve software is a key question that makes it difficult to answer the question of how should you preserve software. And this, it gets even worse when we talk about the whole idea of software as an experienced medium. So this is a still from a computer game called Journey, where you play a character who goes on a walk through a desert, sometimes interacting with other people that you meet. So this is a networked game where you have minimal interaction. The only thing that really happens if you meet someone else is that there are little noises that play. But the way that this experience unfolds is arguably very, very difficult to capture. So here we have, again, kind of coming back to Andy Warhol's time capsules, this sense of software is really like trying to preserve artworks, because so much of the intent of what software does is in the experience and the experience of people who interact with it. So how do you capture that? You could basically preserve the software, you could emulate it, but without the other players, what does that mean? So how can you ensure that if you were to go back to this in 50 years' time, you had an understanding of what it meant to be using this piece of software at the time when it was first released? But this isn't something that's new. It's something that we've had to deal with a number of different times in the past. The most obvious one is around email archives. So one good example of this is the Enron email archive. So here, what we have is, fortuitously or not, depending on whether you were part of the global collapse that this precipitated, you had the release of a large corpus of emails from the Enron organization as part of the litigation against it. And what this has allowed researchers across the world to do is get a sense of how people talk and how people communicated by email. Because you've got all of these different emails, and they're not censored or filtered in any way. They represent all of the different ways that people communicated in that company, and indeed generally in a certain segment of America at that time. Why is this useful? For a long time, the Enron archive was the main corpus that was used to train things such as machine learning for doing text processing and natural language processing. And this is something that we might be able to understand and learn from in terms of doing software preservation. Because again, the reason why this is interesting isn't necessarily because it's the company itself, Enron. There will be people who are researching that specific organization. It's interesting because of the byproducts of what it gives us. It gives us an insight that is captured into everyday life based on the way that people talk to each other. And so this interaction is what I'm getting at in terms of software preservation. How do we capture the interactions both of a user with the piece of software, of a piece of software and another piece of software, in such a way that we understand the impact that these are having? And this is kind of increasingly true as we go into understanding how we capture the entirety of things like social movements. So we've had a number of campaigns recently which have been very much driven by technology. They've been driven not just by the standard processes and rules and guidance of how we create and form community movements, but also they're based on the technology that is allowing them to scale rapidly. So as well as social media, we have political organizations using many different pieces of software to understand who to get a message to, how to get it, and how to ensure that people are cataloged, indexed, searchable, and so on. So in some sense, we've almost flipped it round. Now what we have is we are the things that are findable, accessible, interoperable, and reusable, and the software itself is the thing that's hidden. And this is true once we start going into other areas. So obviously, we know all about fake news these days, but how do we combat fake news? The easiest way of doing this might be through better journalism, more transparent journalism. And one way that some reporters are doing this is by using software to basically put all of their working out there on the page so that other people can see it, analyze it, and check it. And in particular, this is an example of something called a notebook, an electronic notebook. In this case, it's called a Jupyter notebook. And what this allows you to do is intersperse text and code and visualization. And it means it's a very effective way of creating an article that is interactive. It truly is something where if you wanted to, you could go to this particular web page and you could go and change some of this data. So this is This is something where someone has tried to replicate a study around basically the application of the Bechdel test to movies, where the Bechdel test is an indicator of effectively how gender equal a movie is in terms of the characters and their communication with each other. And so this person has taken a study and tried to replicate it and published it in a way that other people can look at and alter and reuse. And our big challenge here now is this is one of the most common pieces of software that is gaining prevalence in terms of being published today. Because of the ease in which you can mix both the paper side and the code side, many people in different fields are using this. The LIGO experiment, which was looking at gravitational waves and won the Nobel Prize a few years ago, they published their results as a Jupyter notebook. The World Bank is starting to use these for many of their different reports into world economies. Netflix, I discovered the other week, are using these kinds of notebooks to do analysis of their customer base. But this is a big challenge because now, again, this isn't just software. This is software that's directly kind of combined with a whole load of different types of objects, which makes it even harder to preserve. So if we just had the source code, it's quite easy. It's a piece of text. Now we have different pieces of source code, different things which are being generated when the paper is read, and a whole set of dependencies that might be required to run and generate these different graphs. So this is kind of going to where I'm coming from. So my background is in helping researchers understand how to make their code sustainable and how to make their code available for people in the future. And there's a whole load of work that's been done in this area, and it's been going on for a long time. Warren Lyford Delano put up this wonderful quote now 15 years ago, where he said that one of the greatest challenges facing research was basically that we weren't publishing the software and making it available for future people to use. So we weren't preserving the software. And he saw that as being a real hindrance to the benefit of all society, because if we don't do this, what we're basically doing is not disseminating scientific knowledge. And the challenge we have here is that since he said that, we've gone from scientific software, computational science, from being a relatively niche part of all research to being just an everyday thing. And what do I mean by this? GitHub is probably now the world's most popular repository for doing code development. It's used by large companies. Microsoft use it. Well, they liked it so much they bought it. IBM, so on, but also loads and loads of individuals from across the world. And there are some really startling things that you get from the report that they release every year about the size and scale of a repository like this. And the thing that really strikes me is there are now 96 million repositories on GitHub. Probably we've reached 100 million by the time that, today. But a third of those repositories were created in the last year. That's an amazing kind of rise in scale of the amount of software that's being produced. A lot of these things are kind of research projects. So PyTorch is the fastest growing software project on GitHub just now. Universities, you might think it's all of these big corporations. Universities were 5 of the top 10 contributing organizations to GitHub in terms of the number of commits and lines of codes. So we're talking about literally billions of lines of code, many of which are being created by people at our different organizations. So how do we deal with all of this stuff? We are also told, and this is what I really care about, that one of the reasons why we should be sharing and preserving software is that software is the key to reproducibility. And reproducibility is basically the way that you can be sure that the results of your science, or indeed the results of your engineering, if you're doing a CAD model, or the results of your research and understanding into poetry are valid. And you can do a number of different things to improve reproducibility. Sharing is one of them. And the challenge here is that most people don't share. Most people don't publish software. There have been some great studies done in this. So one study was done in the field of computer science. So you might imagine that computer science, you would have really good practice around the sharing of software. So this is basically 601 papers published in 1 year in computer science. As you go through, you discover that only 226 of them actually share the software that was associated with the paper in a way that it is usable. So most papers in computer science don't allow reproducibility. And indeed, only about 85, so the ones on the far side there, actually provide the software directly. You don't have to go and hunt for it. So that's in computer science. It's no better in other areas. This is a study that's been done by one of the main people who've been working in this area, Victoria Stodden, and I think it's remarkable for a number of different reasons. So the first one is that it shows how different policy changes can be used to understand whether or not we're doing the right thing. So in 2011, Science, generally regarded as one of the top 2 scientific journals in the world, changed its editorial policies and basically said, if you get published in this journal, you have to preserve the software that was used to create the science that you are disseminating. So that's great. So what we have is a really clear line where before 2011, people didn't have to preserve their software. After 2011, people did have to. So what can you do then? You can go back 5 years later and ask people, can we have your software? And the thing here is basically most people, despite what was required of them, could not give the software. So it was about a third of them that did. So a third of the people had managed to preserve their software in some way, even if that was just by sticking it on a website or a USB stick or a hard drive that was kept in a drawer. What I found really interesting, and you should look at this paper if you want to be both amused and horrified, were the kinds of statements that were given about why people didn't want to share their software. So the top one says there, when you approach a PI for the source code and raw data, you better explain who you are, whom you work for, why you need the data, and what you're going to do with it. So this is an author replying back and going, I don't care what the journal says about preserving software. It's mine, and you can't have it unless you tell me what you want to do with it. So here's another challenge with software preservation. Unlike some other things, people really feel that it's something that they do not want to share. And so trying to get past this kind of culture, trying to persuade people that there is a reason why you want to make sure that this is available to others in the future can be very difficult. That's why from my organization, we often make a distinction between preservation and sustainability. And I know that different people will have different meanings of the two words. So when I think of preservation, I think of things like seed banks, where you're looking to take a particular object and store it in ideal conditions so that it can be revived at some point in the future. When I think of sustainability, I think of things like community gardens, where what you're trying to do is teach the practice of how you grow the thing so that you can continually adapt as conditions change. Different people might consider this in different ways. So for instance, you might consider that software preservation as mentioned on the left-hand side, the seed bank is akin to making sure you have the original hardware, making sure you have the original media that the software came on, and keeping everything as kind of similar as possible to what you had when the software was first released. Whereas the kind of community gardens thing might be around the idea of migrating software, so that you're constantly updating all of the dependencies and so on, so that you can continue running the software. So this is partly about why you're trying to preserve the software. Is it so you can see what it was like at the time, or is it so you can make use of the functionality in the future? And there are many different kind of options going from the sort of the hardware preservation all the way through to the migration, which include things like emulation, which a number of speakers will talk about later on today, about basically different ways of doing things from a documentation perspective, and different ways of understanding how to change the way that software is encapsulated and described. But overall, there are normally about 4 different reasons why you're looking to do software preservation. And a little while back, with some work that was kindly funded by JISC, we looked into the sorts of broad categories as to why you would do software preservation. And they kind of come into these 4, which I've been giving you examples of through this talk. So the first one is achieving legal compliance. So there's some reason why you need to keep the software so that you can understand whether you have met either some particular law, or you have some reason to do it to protect your reputation. And this is an example such as LOTAR, but I think it's also an example that Natasha will be talking about later on in terms of software decommissioning. Another reason is creating heritage value. So this is the idea I was talking about, what happens when you experience a piece of software. What is it that you understand about the way that people are using it that's important to kind of keep for future generations? A lot of digital artwork comes into here. There's some great archives such as the Salman Rushdie archive, where the reason why you're preserving his computer and the software that's on it is to get an idea of his day-to-day routine as he was writing a particular book. So was the fact that he was able to play Minesweeper important for the way that the Satanic Verses was written? It's a good question. In many cases, and this is the main one that I tend to work with from my organization, it's about enabling continued access to data and services. So this is kind of like the Doomsday Project example. You're wanting to make sure that the data that you've collected is still usable for other people in the future. So this is about software enabling continued access. And this happens a lot in science, but it also happens a lot in many different areas. When you think of anything that is to do with ensuring documents, that digital documents can continue to be read and so on, in some way this is also part of the flip side of preserving the software that is required to do this. And then the last one is the one that increasingly we're seeing, which is around encouraging software reuse. So understanding not only how people can use software that was already created, but perhaps extend or build on software. So a large part of the open source community movement is around this. But perhaps it's just understanding how things were done in the past so that you can build better things in the future. And for this, the key thing is that you need more than just the binaries. You need to be able to inspect the source code to understand what decisions were made. You need to have an understanding not just of the software itself, but things like the issues, the internal communications that led to all of the different decisions that were being made. And so the big thing around software preservation is it's all about decisions. There are many different approaches you can use to do software preservation. As I mentioned, you can do things like emulation and migration. You can basically choose to do managed deprecation. There's lots of different ways that you can assess the way that you want to take forward a piece of software. The challenge is that the choices depend on a whole set of different factors, and most of them change as you go through time. So what might be a good approach at one point in time may not be a good approach at another point in time. A good example here is any piece of software which relies on a specific piece of hardware. We have some examples of this when we're talking about, for instance, software that's used in long-term space missions, where they're reliant on very specific pieces of hardware, or in things like nuclear safeguards, where you're putting a piece of software associated with a particular device into a foreign country, and it needs to stay there for a long time. As time goes on, you need to make assessments as to whether your preservation approach is still correct. But the challenge here is that doing so might be more costly. So you're balancing effort and cost and suitability. And so one particular way you can look at this is in terms of the life cycle that you see software going through as it goes from development through to archival. And a lot of this is represented in the different types of repository it uses. So typically software is now developed in a code repository, something like GitHub. It may then be published into a digital repository to make it available. This is where it can be interesting because a good example of a publishing repository might be a website in many cases for many people, but it might also be doing this for physical media. It could be through something like the Valve or Valve Steam Store, an electronic distribution mechanism, and it may involve things like DRM. So this middle step is where there's a vast variety of different ways of doing things. And then eventually it may make its way into an archival repository. And I know that Roberto Di Cosmo is going to be talking next on an initiative called Software Heritage that is doing this. We also have other examples such as the Internet Archive, which is doing a great job of taking whole collections of software and preserving them for the future. And here it's really around the emphasis that's being placed and the rate of change in those different repositories. So when you're talking about code repositories, things change very, very often. The most popular repositories will see changes happening every minute. When we're talking about archival, what we're aiming to do is have things change as little as possible, obviously. So how do you kind of go from one to the other, and when's the right time to take snapshots of software to allow for software preservation? And then what are we doing about things like reputation? So I mentioned that legal compliance was a big thing. Actually, a lot of software preservation is aimed at reducing risk in some way. It's about understanding how we can reduce the risk to the future generations, either because we need to understand whether something was correct, or we need to understand whether something was done the right way, or just because we need to understand who did something. So how do we deal with the fact that most of software preservation and the challenges are not necessarily technical ones, they're social ones? I mentioned reproducibility. The challenge of reproducibility from my perspective is that it's not something that can be handed over to experts at the point of preservation. It's something that needs to be built into the development of the code itself. So what we're talking about now is a two-way communication between the people who are trying to preserve software and the people who are trying to develop software. So both sides need to change their practice to enable software preservation. I talk about reusability as well. And the challenge here is that actually it's very difficult to reuse software, that even software that is well maintained in kind of like just a few years. So if you think about this, if you think of favorite pieces of software that you now can't use because, for instance, Apple has upgraded its operating system from 32-bit to 64-bit, breaking a lot of the libraries that things rely on. There was an example recently where one particular library was taken out of a very common programming language, and it broke about 2/3 of the programs that were written in that language. Just earlier this week, we had the expiry of a certificate from Firefox and Mozilla, which meant that a lot of the Firefox add-ons and plugins suddenly stopped working. So there are many different reasons why actually it's quite hard to ensure that software is reusable in the future. So the question is that what we're aiming for? What is the thing that we're trying to do when we do software preservation? Is it protecting reputation? Is it making things reproducible, or is it that really hard one, making things reusable? So I'm just going to finish off now with a few different examples that I'm not going to, so I've put my slides up elsewhere so you can view them at a later date. One piece of work we did last year was to start producing some guidelines for how you might do the first stage of software preservation, which is for the author of a piece of software to make it ready for deposit. And there are many different reasons, so we've talked about why they might choose to do that, but what we wanted to do was also capture how people benefited, so whether that's around improving the quality of their software, or improving the trust in it, or because they wanted to make it more available and get credit for it, and understand all of the different drivers that kind of go into depositing of software. And we've released this down here as a set of linked guidance that kind of takes people through the how, the when, in this case particularly for software that is involved in research. Why, when you would deposit software, is it when you publish a paper? Is it when a project is coming to an end? Is it because it's a significant version? So that people can be walked through the initial steps of understanding the right times and the right reasons to do software preservation. And if you want to find out more about that, please do go to the website there to take a look. So, the last thing I wanted to talk about was the fact that things are also changing. They're changing a lot in research software, but they're also changing a lot in terms of software in general. And the big thing that's driving this is industry moving towards different technologies for the creation and publishing of software. So I've mentioned Jupyter Notebooks. So Jupyter Notebooks and other associated technologies like Binder allow for this mixing of code and documentation and visualization. The other big thing that's changing is the use of something called containerization, where Docker is probably the leading standard in this area. So what this means is that software is encapsulated. In effect, it's exactly like Andy Warhol's Shoeboxes, where it's all put into this lovely neat box so that people can easily ship it around and then use it on their own machines. It's great because what it does is it gets rid of a whole load of the challenges around dependencies changing. You're able to specify what dependencies are required and ensure that the software that you care about is shipped with the dependencies that it needs. But it presents other challenges, because then what are you trying to preserve? You're now not just trying to preserve the one piece of software, you're trying to preserve the whole potentially Docker ecosystem as well. So how do you preserve the things that help preservation? And there are many different aspects towards that, and it's something that's still very much a piece of ongoing kind of research and understanding. So there are a number of different people who are doing things in this area, as well as the different speakers today. I wanted to point out two other things. So the first one up top is something called the Software Preservation Network, which some of you may be aware of. There have been some joint presentations and webinars done between the Digital Preservation Coalition and the Software Preservation Network on a whole set of different aspects, and they're available through the DPC website. So I strongly encourage you to take a look at some of those webinars, because they cover a lot of the aspects that are really tricky, from things like legal compliance, which we'll hear later on from one of the Software Preservation Network team, to the challenges I've mentioned around containerization and encapsulation of software. There's also another thing that I'll mention called Wholetail, which is something coming out of the research domain, where they're trying to understand how you do capture all of the elements that represent the journey a piece of software has taken in its production. So not just the software itself, but the decisions, the documentation, the reasoning, and the other artifacts. And then there are some other great resources that I'm not going to go through in detail, but I have some links in my slides if you want to find out more, particularly what's going on the academic and research side. So please do take a look at the slides later. So, take-home messages from my talk. I hope you're not too daunted by the fact that software has many different complex dependencies and interactions. It's the big thing that makes software challenging, the fact that very small changes in the environment in which a piece of software sits in can make it very hard to preserve, reuse, recover pieces of software. And I think the key thing here is that it may require knowledge, expert knowledge from outside your team. So you may need to bring in additional support to understand how to preserve software. Sometimes, and ideally, that might be someone from the original development team or the field, so you can ask them questions about why they did something in a particular way. In other cases, it might be someone who is skilled in a particular technology that has been used to make the software more portable or easier to disseminate, but makes it harder to preserve. Another thing is that whilst preserving source code has become a lot easier, and whilst there are a lot of tools for preserving binaries and services, those kind of compiled versions of software are still very hard to preserve, even with this new technology, such as containerization, emulation, and so on. And I think the key thing that I want to kind of get across is when you're talking about software preservation and you're having to deal with it, the real challenge is understanding why you're doing the software preservation, because that will really inform how you do software preservation. If you don't understand the reason why you're doing it, then just like with Andy Warhol's time capsules, they're not time capsules. What you have is software which is really just a shoebox full of junk. So, thank you very much.
I'm just going to take a few questions. So excellent to Neil for Speaker of the Day, kept to time. So we have time for just a couple of questions. If anything Neil said just sort of jolted a query, or if anybody has sort of a comment or something they want to add. At the back, yep, hold on. If you just wait for the mic so that everyone on the stream can hear you as well.
Can you hear me?
Yes.
Thank you for an excellent talk, wonderful talk. I would like to suggest that, and you were hinting at this as well, is that software preservation in all its forms begins even before the software is written, or it should. And you talked about reproducibility. You were talking about it in terms of reproducibility, for example, of scientific results that depend on a particular software. But what about if preserving software and all its dependencies in this sort of infinite net of dependencies is really too difficult or too costly to do, what about being able to reproduce software by going, as it were, to the thing that is done before? So, for example, if you wanted to reproduce a building from, 3,000 years ago, it would be infinitely easier if you had the blueprint of the building. Similarly, if you wanted to reproduce a piece of software, it would be infinitely easier if you had a full set of data models, specification requirements, etc., that were done before any code was written at all.
Yeah, I think that's a really good point you make there. And I think in many cases, that does make... so we were talking last night at dinner about this idea that actually, probably it's the 80-20 rule again. Like 80% of software is probably easier to reproduce, to preserve, and also to reproduce, because you can go and do something like that. You might go to a pseudocode algorithm. You might be able to describe this at a very high level and rely on a cascading set of different documentation to ensure that you can recreate everything that is required. But there's another 20% of software which, for varying reasons, mean it's much harder to use that approach. One example is where it's software which is of a scale that actually a lot of the things can't be accurately described in things like data models and so on, or because it's of a scale that actually you don't have a good sense of whether the documentation you have will give you the result that was gained from running that software. So a lot of things that are running on internet scale are like that. I'm sure that, for instance, Facebook have a lot of documentation and a lot of data models that describe how their infrastructure works. Is that the same as understanding how to preserve the actual experience of using Facebook? Probably not. So I think you've made a very good point there. The other challenge I think I was hinting at is that for the 80% of software where that is a good option, it's still a challenge to get people to do that work. And I think one of the key things for us in this room is to understand how to make it easier for all of this software where this approach does work, to make it easier and to change that cultural barrier about the idea that this takes effort, so that more people do this up front.
Thank you.
Any other questions? We probably have time for one more. Also, no such thing as stupid questions. So I know Matthew Addis won't have a stupid question. If you'll just wait for Alison to bring around the mic.
Hi. So you talked about different reasons for preserving software to, for example, preserve the original software, or to preserve its intent, its function, or to preserve an experience. Could you say a little bit about how you might validate or test or measure whether you have correctly achieved that or not? So if you take one of those approaches, how do you know you've done it okay, and the thing that you are therefore carrying forward is authentic and represents your starting point?
Oh yeah, you've basically hit upon the actually probably $100 billion question here. So I think this is still something where, as a set of different interlinked communities, we are still struggling to understand. I was reviewing something last night, actually, where one of the things that they were proposing to do is look at this, but the challenge here is understanding whether or not that is correct. So, for instance, a commonly used process in industry, particularly software engineering industry, would be to go through some form of quality assurance of the code. But the challenge here is that actually the number of studies done into how effective different types of doing quality assurance, there are remarkably few that kind of go really deep down into understanding how these processes can be transferable. So you'll find that you can get really good quality assurance methods that work for a particular organization but do not necessarily work for another organization. And so that's a huge challenge. But the point here, I think, is that most of the studies show that having some set of processes does improve the quality. The other question is, what does it mean to improve the quality or the correctness of a piece of software? And particularly if you're starting to go to the idea of an experience or an interaction rather than a number that's produced from a formula, it's very hard to quantify that. And there, what you start needing to understand is effectively a whole side of things around ethnology and sociology and anthropology to understand whether or not the way that people are experiencing the software is the same. And sometimes that cannot really be tested in a quantitative way. So I think the challenge here is that the expertise that we need to draw on actually comes from a much wider set of domains than we think it does.